Hello everyone, my name is Tyler Artz and I'm an engineer here at RESPEC in Rapid City, South Dakota. I'm part of our Mine Geomechanics group in our Mining and Energy division. I graduated from the South Dakota School of Mines and Technology with bachelor's and master's degree in mining engineering. In my past, I've worked in coal and gold mines, heavy equipment, and now I'm in the consulting world. What I've done is I've taken the experience that I've learned and we provide consultation to clients for safe mine planning and analyze mine stability. And I'm going to show you a little more about what that is. Mining is extracting material from under the Earth's surface and processing the material to build practically everything we use today. Mine materials can be found in road construction, metal on your vehicles, jewelry, and several components in your cell phone. And the list goes on and on. It's our job to make sure that the extraction of those materials is done in a safe and efficient manner. We use a variety of software and technical experience to provide our clients the best possible solution. I'm going to walk you through the process of how we develop our recommendations. Not only can mining occur in the surface, just as I showed you before, but mining can actually also happen underground. This is a simple drawing of Earth's subsurface. As you can see, there are several layers of material that are stacked on top of one another. They can be composed of soils, clays, rocks, sands, or even salt, which is a lot of the industry that we're in. Let's say we want to mine this area down here at the bottom. Because this area is a bunch of load from the weight of the materials above it, we want to understand the stress field acting on this area. Depending where you're at in the world, this can change greatly and determine how your rock is going to behave when this area is mined out. Stresses want to be in equilibrium, so when you remove a portion of the material in the ground, that unbalances causes the stresses to redistribute. Which, if not done properly, can lead to unwanted events. The key to mining is to make sure the excavation you're creating is stable to support the various activities occurring underground. Mechanical support, such as rock bolts or mesh lining the walls, can be used to increase this factor of safety. The first thing we want to do is identify the different geological layers that are around our area of interest. The best way to do that is to drill and core the material and bring it back to our laboratory where we can characterize and run several mechanical property tests on it to determine its strength. Here are some examples of what the rock looks like after it's been cored out of the ground. The two samples on the left are from salt, and the two samples on the right are from hard rock mines. It's crucial that we know what depth this material came from so that we can accurately characterize the geological strata. Prior to testing the material, we have to machine a sample that looks similar to this. Once we machine it into specific dimensions, we can take it into the lab to find out what its strength properties are. All of these machines around us have the capability of performing various tests on the samples to determine geomechanical properties such as finding out its strength. We're able to control the temperature and pressure applied to the samples to simulate it as if it was still underground, untouched. This piece of equipment will apply loads around the sample, and using various measuring instruments and equations, we can interpret the strength parameters and characterize that material. The strength is determined when the sample fails. So what was once an intact specimen now turns into this as a greater load is applied to the sample than it can handle. What's unique about salt compared to a normal hard rock is that salt doesn't necessarily fail completely as soon as the material is fractured. Salt will tend to dilate or create microfractures throughout the material so it can sustain additional load prior to completely failing. So mining in a salt formation can have a completely different effect when mining into hard rock formations. So now that we've characterized the various geological strata and their strengths from the tested samples that we chose earlier, we can create a three-dimensional model using computer softwares to simulate how mining can affect the stress regime around the area of interest and how the excavation themselves are impacted over time. Here, I've created a basic simulation that incorporates the various geologic stratigraphy and a potential mine plan. What you see is the excavated drifts that a mine could propose to do. The figure shows a cross-section of a geologic column and a potential mine plan where a pattern of drifts are excavated around the supporting pillars. The software can run simulations to calculate the stress distribution around the excavation, and knowing the strength parameters of the material can provide us factors of safety around the mined area. From the analysis we saw from the computer, we can provide recommendations on how to mine the ore bodies that our clients are after. To increase the safety for the miners, rock bolts or steel mesh can be installed, as you can see all around us. These engineered solutions will support the rock around us so mine development can continue to move forward. Because of studies like what I've shown and the principles shared from mining engineering, I feel safe with thousands of feet of rock above us. So if you're curious on more details on what mining engineers do, feel free to come see us. We'd love to show you around sometime. Appreciate you guys hanging out, but I've got to get back to work.